Hi, welcome to my YouTube channel. I am Dr. Abdul Wahab Animoku and I'm a college maths instructor. In today's video, we're going to look at a problem on set theory, how to find the operation of sets that has to do with intervals. So let's get started. Now, this problem, the best way to approach set problems is if you can have a visualization for how the set, for the elements in this set, that would give you a good head start on how to solve the problem correctly. So for especially a problem um, that has intervals, the best way to approach it is to draw the set on what we call on a real line. Okay, so let's get started and let's see how this can be done. So let me choose. So let's say you have a real line. So the first thing is we need to draw set A, B, and C on this real line to actually have a feel for what the elements in this sets are before we go into these problems. So here is 0. So let's write some critical values to get A. A is a set between -3. So let's say here's -3 and here's 5. So let's quickly just draw A. So what A is just, remember that what? So let's use this. So remember that, right? So remember in set A is between -3 and 5, where 3 is not inclusive, but 5 is inclusive. So it means that in this set, all numbers or real numbers between -3 and 5, where -3 is not part of the set, but 5 is part of the set. Now this is set A. Now let's go to set B. So what is B? B is a set between -2 and 7. So here's, of course, here will be -2. So here will be -2. Here will be -2, and here is 7. And it's an open set, which means that what? At the boundaries are not part of the set. So this is what we have for B. And finally, for set C is between -4 and 0. So basically here, say here's -4. So as you can see, -4 is included in the set, but 0 is not. So this is what we have. There is no, so this is C. Now, looking at this picture, this will go a long way to help you, understand how to operate between those two sets. So if you have union, intersection, complement, we'll know how to arrange it, or even difference between the sets would have a way of knowing exactly what elements are included and what elements are not. So let's look at the first question. The first question says we should find A union B union C. Now, what is union? Union basically means all elements that are either in A or in B or in C, right? So anything that is contained in A and B and C together, we have to combine all of them together in one set without repeating an element more than once. So let's do this. So if you see, if you look at the real line, what we're basically doing is we're looking at the leftmost up to the rightmost. That's how we find the union. So basically, without, of course, we have to check if there is any part that is not inclusive in the set. So what we say is that there's a continuity from -4 to 0, and then we still have some elements moving from 0 all the way to 7. So basically, this set would contain all the elements from -4 up towards 7. And we have to represent it with the endpoint. So -4 is part of one of these three sets. In fact, it is part of C, so it will be part of the union. But 7 is not part of this set because 7 is not part of B. So this is what we have. So this will give us the union of the three sets. Okay. Another way to look at this, a method I generally teach my students to use. We can do this thing. We can also solve this problem looking at two sets at a time. So you can start with A union B first, and then once you find this answer, we now find that answer this union C, right? You can also solve it that way. Now let's look at A union B. Now, one of the things I teach my students is when you are looking at union, you look at the minimum of the two numbers on the left-hand side and maximum of the two numbers on the right-hand side. And then you add the boundary, whether closed or open, whether this or this, whether this or this, depending on what we have on that minimum and what we have on the maximum. So let's use this approach to solve the problem. So A union B would be, so we have A, so let's do this first. A is between -3 and 5, and then B is between -2 and 7. So A union B would then be what? Now we take the minimum of what? 3 and -2. So on the left-hand side, we look at the minimum of these two. So the smaller one is -3, so -3 would come here, right? And then we look at the maximum of 5 and 7. So we check 5 and 7, take the maximum of those two, and that is 7. And we have to now accompany this with the boundary that comes with the minimum. So the minimum is -3, it comes with what? Open. And the maximum is 7, it comes with also open. So that is A union B, okay? Now we are going to now find the union of this set with what? C, which is a set so C is a set from -4 to 0, okay? Right? So we need to now find this. And what would this give us? Again, minimum of -3 and 4, and -4 is -4. Maximum of what? 7 and 0 is 7. A -4 comes with closed and 7 comes with open. So this gives us the A union B union C. All right, that's the solution to that. Now let's come to the second question. Second question says A intersection B union C. We already know how to find B union C, so let's just quickly do that. So B union C would be, would be minimum of -2 and -4, which is, so this is A intersection. So we are finding this set now. B union C is just minimum of -4 and 2, which is -4 with closed bracket, and then maximum of what? 7 and 0. So we're checking the end term. Maximum of 7 and 0 is 7 with what? Closed, right? So that is A intersection B union. So this is B union C. Now A intersection, this would give us what? So for intersection, it has the opposite rule of what? A union B, of union of two sets. So for intersection, if I want to find intersection of two sets, let's say two sets, A and B, let's say, what will happen is like we'll take the maximum of the left-hand side and minimum of the right-hand side. And we also accompany this with the with either open or closed interval, right? Depending on what this maximum has and what this minimum has. So for this problem, let's just take a look at it. So it means minimum of what? It means maximum of what? -3 and -4. The maximum of these two numbers, -3 and -4, is -3, right? And then it comes with the open interval. And then we now look at the minimum of what? 5 and 7, which is 5. It comes with 5. 5 is the smaller number between 5 and 7. 5 is the smaller number, and then it comes with a closed set. So this will be the solution to the second one, okay? Now, the third one is a little bit tricky, and this is where we need to use the real line, okay? So the third one, so let's just look at the third one, right? So what is difference? Difference of two sets. So difference of two sets. So let's say we have A, difference B. Now what this means is what? All elements in set A, but not in set B. This is what we mean by difference of these two sets. So it is easy if we have a discrete set of data, that will be easier to find. But when you have a continuous set like we have here, which is an interval, it is not so easy to find. And we have to use the real line to help us to determine this. So let's just consider this two sets on the timeline, on the real line, and then let's see what they are made up of. Okay, so we have them before, so let's just quickly do that. A difference B, so A is between -5 and -3 and 5, right? So That's between minus 3 and 5. Okay. And then B is between minus 2 and 7. Make sure that when you're drawing the real line, everything matches, right? The order, you see minus 3 is the leftmost, and minus 2 is comes before minus 3, and so on and so forth. Now we have this. Now the difference between these two sets means this is A and this is B. This, like I said before, this means what is in set A but not in B. Now you have to check. Now, this is the part, you can agree with me, between minus 3 and minus 2 would be the part that is in A, but not in B, right? Now, if you check everything else that is in A, between minus 2 and 5, they are also in what? B. So our possible answer for A difference B would be what? These intervals between minus 3 and 2. Now we have to also check the boundaries. And the question that you need to ask yourself is minus 3 in set A, but not in set B? If you can see, minus 3 is not even in set A, so it cannot be part of the difference. Okay. What about minus 2? Is minus 2 in set A, but not in set B? Yes, minus 2 is in set A, but it is not in set B. As you can see, there's a hole here. So that means this is part of this difference. So this will be A difference B. Good. We'll also do the same thing for what? B difference C. Now for B difference C, you draw B, which is minus 2 to 7. So I think this is easy to draw now. And let's check set C. What was set C? Set C is between minus 4 and 0 with minus 4 inclusive. So between minus 4 and 0, this is set C, right? This is set C, B and C. Now, B difference C would mean the elements in B but not in C. So if you check again, you can see that well, this would be the elements in B but not in C. Anything between minus 2 and 0, they are all in what? In C. So this will not be part of this difference. So what will be part of the difference is what is in B but not in C, which is from here from 0 to 7. As you can see, it has to be from 0 to 7. Now we have to check the boundaries again. Now we have to ask, is 0 in B but not in C? As you can see, 0 is in B but not in C, right? Because there's a hole here in C. But you see there's a line passing through 0 for set B. And then what about 7? Is 7 in B but not in C? 7 is not even in B. You can see there is a hole here. 7 is not in B, so it cannot be part of this set. So it's going to be open. So now we have A difference B and we have B difference C. So now we need to find the union. I think this is pretty much easy now. Right? So find the union. Now you could actually use real line to solve this as well, but like we said, we don't have to. Now, one thing that you have to check is this. We cannot say the minimum of these two numbers and then the maximum of these two numbers. Why can't we say that? Because one condition I did not mention is the two sets have to have something in common. They cannot be disjoint. Now, if you write this, if you put these two sets on a real line, you'll see that what? The first one is between minus 3 and minus 2, which is this. And this is open. And this is the first one. The second one is between 0 and 7. As you can see, the two sets are disjoint here. There's disjoint. They are disjoint at this interval between minus 2 and 0. Because of that, we cannot find the union of these two sets, right? The answer has to remain the same. There is no change. So this will be the final answer, right? Because you cannot combine the two sets together due to the fact that they are disjoint somewhere. So the only time you can use the rule minimum of the left-hand side and maximum of the right-hand side is when they have something in common. They are not disjoint. Okay, so please take note of that. All right, so let's move on to the fourth question. The fourth one says we should find B intersection C complement. So that's the fourth one. So B intersection C, I think we can easily do that. So let's just get the sets again. B intersection C, so B is minus 2 to 7, and C is -4 to 0. Now, if you check these two sets, the same thing, you can see that what these two sets are not disjoint. They have something in common. Because they have something in common, then we can use the rule that what B intersection C first. We need to find this first before we find the complement. We see that B intersection C would be the maximum of the left-hand side. So let's check the maximum of the left-hand side, which is what? -2. And then the minimum of the right-hand side, which is what? 0. Now, -2 comes with what? Open. 0 comes with what? Open. So this would be the intersection of these two sets. Now, we are talking about the complement of this, which means we need to find the complement of this set. Now, the best way to represent this is to use the real line, okay? So let's use the real line to complete the problem, right? So now, think you are between -2 and 0. So this is the set B intersection C. Now, the complement of this would now be, it means what is not in this set, but it belongs to the real line. Okay, the universal set. So the universal set is the real line. So when you're talking about complement of a set, you're talking about the elements that are not in that set, but they're in the universal set. In this case, you have all this thing from 0 up to infinity, and then minus infinity up to -2. Now, so basically the complement of this set would be elements from -infinity up to what? -2. In a second, we'll determine the boundary whether it is closed or open. And then from 0 up, union from 0 up to what? Infinity, right? Now, let's determine whether this is open or closed. Now, we need to ask, is -2 in this set? If it is in the set, then that means that what? It will not be in the complement. But when -2 is not in the set, it means that element will be in the complement. Remember the definition of complement, it means elements not in that set, but in the universal set. So -2 is not in this set, but it is in the universal set, so it will be part of the complement. The same thing with what? 0. 0 is not part of the set, so it has to belong to the complement. So this is the answer to the problem. So the answer to this is -infinity up to -2, union, because these are the total elements that are in the complement, right? So that's the answer to the fourth problem. Now, the fifth one, which is A difference B union C. So let's look at the fifth one. So the fifth one is A difference B union C, right? I think that's what I'm getting, right? B union C. Have we found B union C before? I don't think we did. So we should. Oh, okay, we found the intersection, not the union. So let's just use this B and C here to find B union C. Now we know what A is, so let's find B union C first. So what is B union C? It's basically, we can use the minimum and maximum now. So it means the minimum of the left-hand side, which is -4, and the maximum of the right-hand side, which is maximum of 7 and 0, which is 7. Now, -4 comes with closure, with the closed interval, and 7 comes with the open interval. So this is B union C. Now, finally, we need to do A difference this set. Now, what is A? We got A before, which is A is just the set between -3. So here is A, -3 and 5. So now we need to use the real line again. -3 and 5 difference 4, 7. This is what we are looking for. Okay. Now let's do A again. This is -3. Here is 5. So it's open here, it's closed here. Okay. Then 4, 7 is somewhere here to 7. And this is closed. And this is open, right? Okay. Now we are looking for what is in this set, but not here. Not here. Right? So if you look at the first one, what is here but not in the second one would be something from the beginning all the way to what? 4. You can see that the difference between those two sets will fall between -4, -3, and 4. Now in the second, we are going to determine the closures, whether it's open or closed interval. Okay. Now, but we know certainly know it's between -3 and 4. So that would be the answer to this. But now let's determine the the boundaries. Now at -3, is -3 in this set, but not in the second one. -3 is not even in the first set. So this would be, it will not be in this difference, right? Because by difference, we mean what is in that set, but not in the other one. So -3 is not even in this set to begin with. So it will be open interval. What about the second one? Is 4 in this set, but not in this set, but not in the second one? What happens is 4 is in the first set, yes, but it is also in the second set, right? So it cannot be here because we are looking for what is in the first one and not in the second one, not what is in both of them, okay? So this will be the answer to that fifth problem. I hope you find this video very helpful on how to manipulate operation of sets that have intervals, right? So in the next couple of videos, we'll be learning other related topics from anything from polynomials to sequence and series to trigonometry. So I hope, and even binomial expansion. So I hope you'll subscribe to this channel, like and comment below for what type of videos you'd like to see on this channel. So I would see you in the next one.